Hello students, peace be upon all of you. As you can see in the title of the video, today we will learn relations versus functions within datasets. We had two other videos in which we learned how to determine if a graph is a relation or a function, and if a data table is a relation or a function. Today, or in this video, we will learn how to determine if a dataset is a relation or a function. So we have a dataset. Now what's a dataset? It's just a set. Starts with a bracket. Set of data. You can say 3, 4. It could be how much money you earn per day. Okay, or how much. Let's say how much money you earned over 3 days. Okay, you have day 1, day 2, day 3, day 4. In the day 1 you earned $3. Day 2 you earned $4. Day 3 you earned $10. Day 4 you earned $15. Okay. Just a set of data, right? But another way of writing it is this is the x, and this is the what? The y. So another way of writing it would be like this, right? 1, 3, 2, 4, 3, 10, 4, 15. To represent what? To represent something. To represent either a relation or a function. As this is the x, this is the y. x1, y1, x2, y2, x3, y3. Each input was its own what? Output. Now, if you remember in a previous in a previous video that we covered how to determine if a data table is a relation or a function, the very first video about relation and functions, we mentioned that for inputs or for x values, we have a name. We have another name, in which we call domain, right? Domain. So x values or input values represent something called a domain, and y values or output values represent something called the range. So in this case, the domain is all the x values, right? You can say 1, 2, 3, 4, right? As your x or domain. And for y, you have 3, 4, 10, 15. 3, 4, 10, 15. Okay? The range, the domain, and the range. The x values and what? The y values. Now, I just wanted to let you know that within the domain, we call the x values, within the data set, we call the x values the domain, and we call the y values the range. Okay? Just so you know. Now, we need to learn how to determine if a certain data set represents a function or a relation. Now that you know how a data set looks like and how it's represented and what domain is and what range is, let's get to how to determine if a data set is a relation or a function. So say you have a data set. Remember, we said for a function, each x value has its own y value. Okay. If one x value has if one x value has two different y values, it's a relation, right? But if one x value has one y value, then it's what? It's a function. So let's say you have a 3 and a 2, a 1 and a 4, a 6 and a 3, a 8 and 5. Okay, we have a data set. It has how many coordinates? 1, 2, 3, 4. 4 coordinates, okay? We can grab them if you want to grab them, but we can just literally look at this and determine if it's a relation or function. Now let's cover each x value. 3, 1, 6, 8. Any redundant? Any repeated x values? Nope. Each x value has its own y value. Awesome. What does that tell us? If each x value has its own y value, that means it's a function. That means each input has its own output. That means it's not a relation. Not a relation. Okay? Let's look at another example. So you have 4 and a 2, 3 and a 6, 9 and a 1, 3 and a 6. Okay, we have another 4. We have a different data set with 4 coordinates. Let's circle each x value like we did before. Any redundant data or any repeated x value? Oh, there is repeated x value. Now let's mark the y's. The y here and the y here. Okay, the y here is the same as the y here. Good, so each x still has its own y. We don't have different output values or different y values. So is this a function? Yes, it's still a function. Okay? It's still a function. Because 9 has a 1, there's no other 9s. The 4 has a 2, there's no other 4s. There's 2 3s, 2 input values, but they're just being repeated, okay? 6 and 6. That's okay. It still has its own y value. That means we don't have to worry about it, alright? It's still a function, it's not a relation. Not a relation. If it still has, if the same x still has the same y, still a function, okay? But if the y was different, if this was a 6 and this, for example, was a 10, then that would matter. It's no longer a function, it's not a relation. Let's have one last example. Now let's say you have 1 and a 2. Let's say you have a 3 and a 10. You have a 3 and a 4. You have a 6 and a 15. Alright. 1, any other ones? Nope. 3, any other 3s? Yep. There's a 3 here. Okay, a 3 and a 3. So same input value, same x value. Now let's check the y's here. The y and the y. This is the x. Same x values. Oh, the y here is 10 and the y here is 4. Different y values, different output values. So if one input value, has 2 different output values, what is it? It's a relation. It is a relation. Meaning it's not a function. So this is simply how we find, or how we determine if a data set is a relation or a function. We look at each x value, each x value in the data set. If each x value, if there's no repeated x values, then we know that this data set is a function. If there are repeated x values, but these x values still have the same y values, then what? Then it's still a function. But if there are repeated x values with different y values, then it's what? Then it's a relation, not a function. I hope you found this helpful. If anything's still unclear, I encourage you to replay the video. Thanks a lot for watching. See you next video.